Picture this: you are a brilliant engineer at Google in 2007. You are working on massive distributed systems, thousands of servers, millions of lines of code, and every time you change one line of C++, you have to wait 45 minutes for the binary to compile. Or if you decide to write Java, you drown in a sea of XML configurations and abstract singleton proxy factory bean. For three engineers at Google, Robert Griesemer, Pike, and Thompson, this wasn't just an annoyance, it was an existential crisis. They wanted a language that was simple, fast to comply, and built for the modern era of multi-core processors and network server. They call the language Go. The internet calls it Golang, because Go is impossible to search on Google. This is the story of how a language designed by three old guard engineers to solve Google's problems accidentally became the backbone of cloud computing. The three founders weren't hobbies, they were legends. Thompson co-created Unix and the C programming language. Pike was part of the Unix team at Bell Labs and later worked on Plan 9. Robert Griesemer worked on the V8 JavaScript engine. These are people who shaped the foundation of modern computing. They looked at the state of software in the late 2000s and saw a problem. Languages like C++ had become enormous complicated monsters. The C++ standard document was thousands of lines of code long. Compilation times were measured in geologic epochs, and Java required an entire framework of XML just to print hello world. They wanted something different. They wanted a language with the speed of a compiled language, but with the simplicity of a scripting language like Python. They wanted compilation to be so fast that it felt like running an interpreted script. The design goals were written on a whiteboard in 2007. The language was announced in 2009, that is 2 years later. And it was boring, deliberately boring, but that was the point. Go is intentionally minimalist. There are no classes, no inheritance, no exceptions, no generics. For the first 10 years anyway, no operator overloading. The joke was that Go was designed for people who wanted to read code, not write it. Pike famously said that Go was designed for mediocre programmers. He meant it as a statement of intent, not as an insult. He wanted a language that could be picked up by a large team of engineers of varying skill levels and still produce consistent readable code. The language enforces a single guide called Go FMT. It formats your code automatically, no arguments, no debate about tabs versus spaces. The language just decides. The mascot is a gopher, not a majestic eagle or a dragon. A gopher is humble, it digs tunnels, it does its job. It embraces the boring aesthetic. Less is more became a mantra, almost a religion in the Go community. But there was one feature that was genuinely revolutionary. In most languages, concurrency is hard. You spawn a thread and you are managing locks and motexes and waiting for race conditions to eat your soul. Go has a different approach. It gives you Goroutine, lightweight cheap functions that can run independently. You can spawn a million of them without even breaking a sweat. And to communicate between them, you can use channels. One Goroutine sends data into a channel, another receives it. This is based on a model called Communicating Sequential Processes, or CSP, from a 1978 paper by Tony Hoare. Go took an academic concept and made it practical, built into the language itself. Go was built for the internet age. A web server written in Go can handle thousands of concurrent connections with a fraction of the memory of a Java server. It complies to a single static binary, no dependencies to install, no virtual machine. You build it on your laptop, copy the binary to a server and run it. That was a radical idea in 2012. When deploying Java meant configuring WAR files and application servers. Here is where Go stopped being a Google project and became the foundation of the modern internet. In 2013, a company called .cloud was struggling. They had built an internal tool for packaging applications into containers, lightweight portable environment that could run anywhere. They open sourced it and called it Docker. It was written in Go. Why? Because they needed to build a single binary that a system admin could drop into any Linux server, no dependencies, and it will just work. Then came Kubernetes, Google's open source system for orchestrating containers, also written in Go. And then the entire ecosystem of cloud native tooling followed. etcd, the distributed key value store that stores the state of the cluster. Prometheus, monitoring. Terraform, infrastructure as code. Hugo, static site generation. Caddy, web server. The list goes on and on. Go didn't just participate in the cloud revolution. It is the cloud itself. The majority of the projects in the Cloud Native Computing Foundation are written in Go. If you deploy a web application in 2024 or the infrastructure underneath it, the containers, the orchestration, the networking, the monitoring is almost certainly Go. It was an accidental world domination. The language wasn't designed to be the cloud language. It was designed to solve a compile time problem at Google. But the features that solved Google's problem, fast compilation, single binaries, easy concurrency, turned out to be exactly what the nascent cloud ecosystem needed. But the story isn't all smooth sailing. For over a decade, the community begged for generics, the ability to write functions that function on any type, not just a specific one. Every modern language had them. The Go team refused. Their reasoning was that generics added complexity, and complexity is a language. They spent years arguing, designing, and rejecting proposals. The community split. Some called it stubbornness, others called it discipline. Finally, in 2022, Go 1.18 shipped with generics. The war didn't end. The language got slightly more complex, but it remained Go. Go had a distinct cultural identity. It is not for everybody. Programmers coming from C++ or Rust sometimes find it limiting. Why can't I do this? Why can't I do that? Because the Go language decided that you don't need to. The language is optionated. It says no to features that other languages say yes to. Some call this arrogance. The Go community called it clarity. But the numbers don't lie. Go consistently ranks among the top 10 languages in every survey. It's used by Google, Dropbox, Uber, Netflix, Twitch, and thousands of startups. It's one of the highest paying languages in the industry. The golfer is everywhere. Go was born from frustration with slow compliance, frustration with complexity, frustration with languages that had become so bloated that they were more about the languages than the problem that the languages solve. The three founders, Thompson, Pike, and Griesemer, didn't set out to change the world. They just wanted to make their jobs easier, but they accidentally created a language that matched the moment. As the world moved to the cloud, Go was already there, waiting with a single deployable binary and millions of Go routines. It wasn't exciting, it wasn't glamorous. It's a golfer, not a dragon. But boring is beautiful. Boring skills. Boring runs the internet. Thanks for watching.